Hey kids, Flexing Teacher Weber here. We're reaching the end of our introductory unit on algebraic equations. We've been focusing in this unit on developing the equations and the expressions and graphing them. So I want to do a little review where we look at some of the different patterns we might be able to do in graph. So this first one was a graphic artist pattern, and it was cubes designed for each pattern. And when you study this situation, you see that in the first diagram there is 1 cube. In the second diagram there are 4 cubes. In the third diagram there are 3, 5, 6, 7 cubes. And in the fourth diagram there are 10 cubes. So one of the first things we do in these situations is make a table of values. So the kids made a table of values and started to track all the different designs that you could get with these cubes. So for diagram 1, there was 1, and then we said 4, 7, 10. We can see that pattern is increasing by 3 every time. So that means we can go 13, 16, 19. And this increase by 3 is a big deal because it tells us the beginning of the algebra. It tells us we'll always go times 3. Times 3, times 3, times 3. But that's not going to be good enough. In every situation, we want to be able to get the cubes. So 1 times 3 is 3. And then if you subtract 2, that gives you 1. And 2 times 3 is 6. Subtract 2 gives 4. And 3 times 3 is 9. Subtract 2 is 7. So this works in every situation. So that's the algebraic pattern right here. This one right here. Now, how do we express that as an expression in equation? Well, to do an expression, we do the design times 3. So we write that as 3x and then minus 2. And for the equation, we add on the other part, we add on the cubes, which is y. So that's y equals 3x minus 2, or 3x minus 2 equals y. So that's one thing the kids need to be able to do. They need to be able to take up a picture pattern and express it algebraically like this. Now the next thing they need to be able to do is take a realistic pattern. So this situation here says to rent the Golf Dome for a team building event, it costs $250 plus $10 for each person attending. So $250 to rent the place plus $10 for each person attending. So in this case, we wouldn't rent it with 1 person, 2 people, 3 people. We'd probably look at groups of 10 or a larger group of people. So 10, 20, 30, 40, 50, 60, 70. And the cost would be $250 plus $10 per person times the number of people, which is 10. 10 times 10 is 100 plus 250. That would work out to 350. And then 250 to rent the place plus 10 people plus $10 per person times 20 people. 10 times 20 is 200 plus 250 is 450. And $250 plus 10 times 30. And 10 times 30 is 300 plus 250 is 550. So we can see here the pattern is increasing by 100 each time. So then we could probably fill this in and do 650, 750, 850, and $950. Now, what we can see from the pattern here is that every time you're taking the number of people, you're timesing it by 10, and then you're adding on that 250, and that always gets you the cost, right? $350 in that case. So there's your algebraic pattern right there, because this works every single time. If people are x, so for x number of people, any number of people, how do you express this algebraically? You say, well, if people are x, you say x is the number of people times $10 per person plus $250 for renting the place. 10x plus 250. And the equation would be adding on the other part. Y equals 10x plus 250. And y, of course, is the cost. Okay, so there's our algebraic expression and equation. Now, the next thing we want to do is graph this. So getting x and y values. So x and y. And we get these points right from the table. So the points are 10, 350. And 20 people, $450. And 30 people, $550. And 40 people, $650. And 50 people, $750. And I'll just double check that. Yeah, looks good. So there's our points, and here's our graph now. We're going to graph this. We're only going to be in the positive area of the coordinate plane. We got to label the parts of our graph. X is going to be people, where the x and y axis meet is 0, 0. This time we're not going to go up by ones. It would probably make sense to go up by tens, right? 10, 20, 30, 40, 50, 60, and 70 people. Sort of made a little boo-boo right there. There we go. And then, of course, cost goes on the y-axis, cost in dollars. And I better check this out. 350, 450, 550. I'm thinking if I went up every second line by hundreds, that would be sweet. So every line, every single line would be 50s, and I'd be perfect. That's going to make this easy to graph. 300, 400, 500, 600, 700, 800. How far do I have to go here? That's perfect. Okay, and now graphing these points. Oh, and I should name this. This is the Gulf Dome. Name your graph if you can. All right, so we always do x first, y second. So when x is 10, y was 350 right there. Boom. When x is 20, y is 450. Boom, right there. So 2450. When x is 30, y is 550. So across 30, up to 550. Boom. 3550. When x is 40, y is 650. So right there. And you can see we're getting that linear equation. And then finally, when x is 50, y is 750. Now we could have data in between the points here, so I don't see any reason why we wouldn't join these points to show the linear relationship. And we should put the name of our equation on there. This is the graph of the equation y equals 10x plus 250. It's the Gulf Dome equation. Okay, so that's another thing the kids have to be able to do is represent a realistic pattern algebraically, like a pattern that doesn't involve pictures. No, pictures can be realistic. Okay, the last thing they need to be able to do is the opposite of this. So if we jump ahead, given an equation, make the graph from the equation. So this question says, use the equation y equals negative 2x plus 2 to create a table of values. The table should have positive and negative values for x and 0. Make 5 entries. So I'll make my table of values. And I'm going to use different values for x this time, just to change it up a bit. Let's say x is equal to -4, -2, 0, 2, 4. And then we'll use substitution. Y equals -2x plus 2. And we're going to substitute in -4 for x plus 2. That's going to be y equals 8 plus 2. Y equals 10. When x is -4, y is 10. And do the equation again. Y equals -2x plus 2. Y equals -2 times -2 plus 2. Y equals 4 plus 2. Y equals 6. So when x is -2, y is 6. And when x is 0, we can see this is decreasing by 4. It's actually decreasing by 2 every time, but we skipped some values for x, right? So when x is 0, y is 2. When x is 2, y will be -2. And when x is 4, y will be -6. And we can write those values as ordered pairs, -4 and 10, -2 and 6. Think about how you're going to make your graph now. I'm thinking the x values don't go up too badly. We can probably go up by 1s. But the y values, we might have to go up by 2s because there's a pretty wide range in those ones. So for x, we'll go up by 1s and y will go up by 2. So let's skip ahead to our x-axis. I think I'll go up by 1s for the x. So there's 0, 1, 2, 3, 4, 5, 6, 7. And -1, -2, -3, 4, -5, -6, -7. Y values, I think we'll go up by 2s, 2, 4, 6, 8, 10, 12, and -2, -4, -6, -8, -10. So there's your x and y values. When x is -4, y is 10. So we'll go across 4 and up to 10 right there. That's -4, 10. And when x is -2, y is 6. So across 2, up 6 right there. That's -2, 6. And there would be points in between there, right? Even though we didn't list it, there would be -3 and 8 right there, right? The next one is 0, 2. So 0 right here and 2 right there. 0, 2. And the next one is 2, -2. So across 2 and down 2 right there. 2, -2. So we'll say that's 2, -2. And then the last one is 4, -6. So across 4 and down to, across 4 and down to -6 right there. So that's 4, -6. And you can see we get a linear relationship, a straight line. This one will join it. And we'll put arrows on the end indicating this can go forever in either direction. And we're going to call this y equals -2x plus 2. We've now graphed this situation. It's a linear relationship. Yet another way of displaying the algebra. See, these are all the different things the kids have to be able to do with algebra in this unit. They have a review assignment that this video will help with. That's all for now. Have a great day. Flexing Teacher Weber out.